To determine if a three-phase motor has delta or Y windings, several methods can be employed. Firstly, consider the multimeter test for motors with accessible terminals. Begin by disconnecting the motor from the power source to ensure safety. Set the multimeter to resistance mode, which is indicated by the ohm symbol. Measure the resistance between each pair of terminals. If all three resistance readings are approximately equal, the motor likely has delta windings. Conversely, if two of the three resistance readings are nearly equal and the third is significantly higher, the motor likely has Y windings. This difference arises from the winding configuration and how the resistance is measured through them. Secondly, visual inspection can be used when terminals are inaccessible or as a preliminary check. Look for the terminal box in the motor. If the terminals are arranged in a U shape with three terminals on each side, it suggests a Y winding configuration. If the terminals are arranged in a triangle shape with three terminals equally spaced apart, it suggests a delta winding configuration. However, visual inspection is not always definitive and should be supplemented with electrical testing if possible. Thirdly, resistance measurements using a megometer can be used, especially for motors with inaccessible terminals, but exercise extreme caution, and if unqualified, hire a professional. Ensure the motor is disconnected from the power source and fully de-energized to prevent electrical shock. Use a megometer to measure the insulation resistance between each phase winding and ground. If the insulation resistance measurements are low, for example, less than 1 megohm, it indicates that the motor likely has Y windings. Conversely, if the insulation resistance measurements are high, for example greater than 1 megohm, it suggests that the motor has delta windings. Lower insulation resistance typically indicates insulation breakdown or contamination, which can be more pronounced in Y-connected motors due to the voltage distribution. It is important to note that using a megometer requires special equipment and a good understanding of electrical safety practices. This method should be performed by a qualified electrician to avoid potential hazards and ensure accurate results. Always prioritize safety when working with electrical equipment. Double-check that the motor is disconnected from all power sources before beginning any testing. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If unsure about any aspect of the testing procedure, consult a qualified electrician. The nameplate of the motor can offer some guidance. However, if the nameplate information is not clear or if the motor is damaged, it can be difficult to determine the winding configuration using these methods. In such cases, seeking assistance from a qualified motor repair technician or electrical engineer is recommended. They have the experience and tools to accurately assess the motor's condition and winding configuration. Considering voltage for a dual voltage motor such as a 230/460 volts motor, the winding configuration changes depending on the voltage applied. In a Y configuration, the voltage across each winding is less than the line-to-line voltage, whereas in a delta configuration, the voltage across each winding is equal to the line-to-line voltage. Therefore, the motor must be properly connected for the intended voltage to avoid damage. If the motor is connected for 230 volts when 460 volts is applied, the windings will be subjected to excessive voltage, potentially causing insulation failure and motor burnout. The opposite is also true if the motor is connected for 460 volts but is connected to a 230 volt supply. It may not develop sufficient torque to start or operate under load. For Y windings, the line-to-neutral voltage is approximately 57.7% of the line-to-line voltage. This means that in a 480 volt system, the line-to-neutral voltage is approximately 277 volts. In a delta system, there is no neutral point, so there is no line to neutral voltage. The current in the windings also differs between delta and Y connections. In a delta connection, the line current is approximately 1.732 times the winding current, whereas in a Y connection, the line current is equal to the winding current. This difference in current must be taken into account when selecting the appropriate size conductors and overcurrent protection for the motor circuit. For example, if a motor has a full load current of 10 amps in a delta connection, the line current will be approximately 17.32 amps. Therefore, the conductors must be sized to carry at least 17.32 amps, and the overcurrent protection must be sized accordingly. The National Electrical Code, or NEC, provides guidelines for sizing conductors and overcurrent protection for motor circuits. NEC Table 430.52 provides the maximum allowable overcurrent protection for motors, depending on the type of motor and the type of overcurrent protection used. NEC Section 430.22 specifies the minimum ampacity of conductors supplying motors. It is important to consult the NEC to ensure that the motor circuit is properly sized and protected. In summary, determining whether a motor has delta or Y windings involves visual inspection, resistance measurements, and understanding the voltage and current relationships in each configuration. If unsure, consult a qualified electrician or motor repair technician to avoid potential hazards and ensure proper motor operation. Remember to always prioritize safety when working with electrical equipment.